Hello guys, welcome to another problem solving session with Special Maths Academy. It's Obukome Jaife here, and today we're looking at problem 4 of the 2022 Pan-African Mathematics Olympiad held in Morocco, and it's a functional equation problem. So before we go into the problem, let's discuss about the competition a little. A brief history about the PAMO. PAMO is a contest mainly for countries in Africa. So this year Nigeria sent a team to PAMO of 3 students, and of those 3 students, they all won medals. In fact, one of the students, one from Jacob, won a gold medal, and this is his second year of participating. It's currently in grade 10 or SS1, and he's actually winning a gold medal. It's also important to note that there were only 5 gold medals in this year's competition for all the participants, just 5. So for an SS1 student to have won a gold medal, it shows you how good that student is. And one thing that is special, Jacob has been with Special Maths Academy since inception. He has attended all our programs, so he's really doing very well now. And we at SMA were actually very proud of him. So if you're a parent out there or you're a teacher watching this and you want your students to be part of this success story, just head on to our website and you can reach out to us to show you the next steps. So that's by the way. So today we're solving this problem. It says find all functions f and g defined from the set of reals to the set of reals such that for all x, y greater than 0, the two equations hold. The first one says f of x plus y minus 1 in a bracket. Then second one says g of y plus x minus 1 close the bracket times equals x plus y all squared. Then the second one says minus f of x plus y close bracket open another bracket g of y plus x close bracket equals x plus y minus 1 and into y minus x minus 1. So that's the problem. Then there's a side note says arrow greater than 0 denotes the set of positive real numbers. That's our problem for today. So as usual, whenever you have a functional equation, you might want to make some substitutions. So let's first say x equals to y equals to 1. We're not using 0 since we're talking about set of reals greater than 0. So x equals to y equals to 1 in the first equation, you have something like f of 1 plus 1 minus 1 into g of 1 plus 1 minus 1 equals 1 plus 1 all squared. And this means if you simplify, you have something like f of 1 g of 1 equals, this is 2 square, which is equals 4, equals to 4. Then the next thing, the second equation, if you substitute, you have minus f of 1 plus 1 into g of 1 plus 1 equals 1 plus 1 plus 1 into 1 minus 1 minus 1. And then this means that 1 minus f of 1 into 1 plus g of 1, this is 3, this is minus 1. So this is 3 times minus 1, which is minus 3, equals minus 3, right? So you can expand. When you expand, you have something like g of 1 minus g of 1 f of 1. I'm expanding this side now. Expand. Plus, okay, plus 1 minus f of 1 equals to minus 3. And we know that this, okay, let's call this 1 and 2. So we have f of 1, g of 1 is 4, g of 1 minus g of 1, f of 1 plus 1 minus f of 1 is minus 3, right? So we have these two equations or something, yeah. And we know this is 4 from this part. So this means g of 1 minus 4 plus 1 minus f of 1 equals minus 3. Minus 4 plus 1 is minus 3. So this like cancels out, and this means that, and then we have something like g of 1 equals f of 1. Yeah, so we have this. Okay, so how do we use this now? Let's come down a little. So since g of 1 equals f of 1, then you recall that we already had this, and now we have this. So this means that f of 1, g of 1, if I say is equals to f of 1 times f of 1, which is equals to f of 1 square, but this is equals to 4. So this means that 4 equals f of 1 squared, and then when I take square roots, I have f of 1 has to be equals to root of 4, which is 2. Why not minus 2? Since f of x is greater than 0, f is from set of roots to from positive roots to positive roots. So f of 1 is equals to 2. So and this means that g of 1 also equals to 2. So let's clean now. Let's go up and use this info, this new information. Okay, so now we know that f of 1 equals to g of 1 equals 2. So we have this. Okay, the next thing will be to set it inside this first equation. Let's call this 1. Okay, let's just this time let's leave one variable free. Let's set y equals to 1 and leave x free. Guys, when we still leave x free, x can be anything. So this is f of x plus 1 minus 1 into g of 1 plus x minus 1 equals x plus 1 all squared. This cancels out, so this is something like f of x. I will know this is 2, so this is into 2 plus x minus 1 equals x plus 1 all squared, right? Then 2 minus 1 is 1, so this is f of x into x plus 1 equals x plus 1 all squared, and then I can divide through by x plus 1. Since x plus 1 is greater than 0, so we have that. So we know what, so we found out of the two functions. Now we know what f of x is. F of x is x plus 1. So the next thing to do now will be use f of x to find the value of g of x, right? That will be the next thing. So we're still working with our first equation. We continue to work with our first equation. So still come back to our first equation. Let f of x equals x plus 1 in 1. Let me draw a line here, something like this. So this is x plus 1 plus y minus 1 into g of y plus x minus 1 equals x plus y all squared. And when you simplify this, 1 cancels out with 1, like subtract each other out. So this is x plus y into g of y plus x minus 1 equals x plus y all squared. And then I can divide through by x plus y again, because x plus y is not okay. Let me write it out here. Since, and let me write out the reason. x plus y is not equals to 0 on any conditions. So this implies that, then this means that x plus, then so I can divide through by x plus y, so I have something like g of y plus x minus 1 plus x plus y. This goes out. So I have g of y minus 1 equals y, and g of y equals y plus 1. So fine, we know what the functions are, but there's also something we also need to verify that these functions actually like work. It's not necessary at times, but in this case I would advise a verification. So before that, let's write this out, because in some contests a contestant could lose marks for not verifying the function, maybe like 1 point or something. So it will be very painful to solve a functional equation and then get 6 out of 7 points because of some trivial verification you could have done on your own. So let's just verify. But if we are verifying, it would be best to just verify with the second equation, because we already, the first two, the solutions we got, that is g of y equals y plus 1 and f of x equals x plus 1, were basically gotten from the first equation. So we might want to just test if these values also satisfy the second one. So how do we do that? We just, so we know that, okay, if we use our solutions, we know this is minus x plus 1 plus y. We know this is y plus 1. This is y plus 1 plus x. And when you simplify, this is y minus x minus 1 into x plus y plus 1, which actually equals to the right hand side. So the function actually works. So therefore the only solutions are f of x equals x plus 1, g of x equals x plus 1, or g of whatever you use, x. The variable doesn't really matter, you just know what the function is. And we verify that they work. So with that, we've come to the end of this problem solving session. So I hope to see you guys in another problem. But in the meantime, you can watch the other problems, the other solutions on this channel as well. Interact with us on social media. Subscribe to this channel if you've not done so. Follow us on Facebook, Twitter, Instagram at Special Maths Academy. Then our summer camp is also coming up. If you know you want to take your maths contest journey to the next level, just head on to our website, specialmaths.ng, and you'll see the flyer over there, and then you can register online. Then our contest is also coming up. We're trying to put some finishing details in place, working on some details, finishing touches. So pending while we do that, the contest website is open for pre-registration. You just drop your email. So when we actually open registration, you will actually send you a letter informing you that registration is open and you can register. And to be eligible, you have to be between the years of 12 to 18, and you must not currently be enrolled in any university system. Other than that, you can participate. If you're a teacher, spread the word to your students. And the exciting part is that there are over $500 worth of prizes to be won. $500 is a lot of money. I'm not sure you want to miss that. So you're good at maths, and you are eligible to participate, just head on to the contest website, specialmathscontest.com, and drop your email, and we'll get back to you soon. So I'm Obukome Ejaife, and that brings an end to this problem solving session. Hope to see you guys next time. Bye.